Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to go through nuclear fission and nuclear fusion. This is a topic in both the SPM and IGCSE physics syllabus. There is always a lot more to know about this topic, so if you'd like to find out more, please feel free to do your own research or watch my other educational videos. What I'll be covering in this video is the general information that you would need in order to answer the questions in your examinations. This includes what is nuclear fission and its application, as well as what is nuclear fusion and its application. Let's start first with nuclear fission. So nuclear fission is the process of a large nucleus splitting into two smaller nuclei. This is not a random process where it magically explodes into two smaller nuclei. For this to happen, there must be a trigger. And the trigger in this case is when a neutron strikes the nucleus at the right angle, causing it to split. Let's take a look at this animation. So here we have a large nucleus that's just been hit by a neutron. And as you can see, it splits into two larger nuclei and a few random neutrons were also released. Now, an example of a nuclear fission reaction that could happen is like in this case with uranium. So this could happen actually with uranium-235 or uranium-238 isotopes. There are also other elements with which nuclear fission can happen, for example, plutonium. But typically in your syllabus, we focus on uranium. So here we can see that there's an equation and at the bottom there is a diagram. So the diagram shows us how a neutron strikes the nucleus, causing it to split into two fission products, which are the two smaller nuclei, and you can get three random neutrons. This is not a fixed reaction. So like for example, if you look at the equation, we have uranium-235 with one neutron, and it splits into two isotopes of krypton and barium, plus three additional neutrons, and of course, a lot of nuclear energy released. This is merely one example, and you have to realize that the products that we get depend on the type of radioisotope that's been hit by the neutron, as well as the angle and the energy with which they collide. So sometimes you get krypton and barium, sometimes you can get other products like xenon and strontium. It doesn't matter. You don't have to memorize the products. You just need to recognize that this is a nuclear fission reaction. So basically, a large nucleus, for example, uranium in this case, gets hit by one neutron, and that collision causes it to split into two atoms and some spare neutrons. The additional neutrons that are the product could be two or three. Again, that depends on the collision. So just recognize that this is a nuclear fission reaction. Now, nuclear fission can produce chain reactions. What's a chain reaction? Now, as we saw from the earlier slide, some random neutrons could be produced and they're also moving quite fast. So it could be two or three neutrons. And each of these neutrons, because they're also moving, well, not that fast, but relatively fast, they can also strike other uranium atoms, causing those uranium atoms to split and form again two smaller nuclei and even more random neutrons. And those products, those neutrons, can hit other uranium atoms and so on and so forth. So it's kind of like a domino effect. So from one neutron, it splits one uranium atom, and then the neutrons hit other uranium atoms and so on and so forth. So for example, in this diagram, you can see here, the first neutron that strikes a uranium atom produces two smaller nuclei and three neutrons. Two of these neutrons go on and hit other uranium atoms. And then those uranium atom and those respective fission reactions produces two neutrons which also strike other uranium atoms, and this escalates. So from one becomes two, becomes three, and so on and so forth. So in fact, if every neutron were to strike other uranium atoms, from one you could get 3, 9, 27, and so on and so forth. So that's a chain reaction. Just to point out to you, if you look at the individual reactions here, you can see that although the neutrons are all striking uranium atoms, you can get very different atoms. Like you have krypton, barium, some are xenon, strontium, some are cesium, rubidium. So remember, it doesn't matter what the products are. Essentially, nuclear fission is when one large nucleus splits into two smaller nuclei. However, for the chain reaction to occur, there must be enough uranium atoms for the neutrons to be able to hit. So the minimum amount of mass needed for the chain reaction to take place is known as the critical mass. So here's an animation to show us chain reaction. So here's a large nucleus hit by a neutron that splits, and you've got the spare neutrons. Another neutron hits another uranium atom, again it splits, and then you've got another neutron striking another uranium atom, and so on and so forth. So nuclear fission is typically used in nuclear power plants as well as atomic bombs. If you'd like to find out more about nuclear power plants, please watch my educational video where we learn briefly about nuclear power plants, what's going on inside, and what the functions of the components are. For now, let's move on to nuclear fusion. So nuclear fusion now is the opposite of nuclear fission. It's a process of two smaller nuclei forming one large nucleus. So you can see, for example, in this case, we have two smaller atoms, deuterium and tritium, that combine. They fuse together. That's why it's called fusion. They fuse together to form one larger atom, which is in this case helium, and you can also have a spare neutron at the end. And of course, a lot of energy is produced. Now, I don't have an animation in this case, so you need to use your imagination a little bit. Okay, but here is the example of an equation. So again, just like nuclear fusion is not fixed to only these kind of atoms. So you can have different hydrogen isotopes combining to form one bigger nucleus. So here we have one deuterium isotope and one tritium isotope, but it's also possible for nuclear fusion to happen between, for example, two deuterium isotopes. Essentially, what happens is these two smaller atoms combine to form one larger one. Now, these isotopes cannot randomly combine and form one larger nucleus just like that. There must be certain conditions to happen, because you'll find that in reality, in most cases when they collide, they're just going to collide and bounce off each other. For them to be able to join together, the collision must be in such a way that it can force two nuclei to combine into one. So for this to happen, it requires very high temperature and pressure. So very high temperature and pressure causing the particles to move with so much energy that when they collide, the nuclear fusion reaction happens, causing the two smaller nuclei to combine into one larger nucleus. So nuclear fusion typically happens on the surface of the sun. So that's how the sun is able to produce all that heat and light that we get. It's from the nuclear fusion reactions of the hydrogen isotopes on its surface. So just a quick comparison here in case some of you are curious. I know some of you are really interested in bombs. So if you'd like to find out more, please do your own research, not to make your own bomb, just to find out how they work, okay? Educational purposes. So for your information, what we call as atomic bombs, based on a nuclear reaction, right? So what happens inside the bombs is usually nuclear fission. That means the plutonium atoms, for example, are triggered to cause an explosion that produces a lot of nuclear energy. So usually it's one major explosion happening due to nuclear fission. That's an atomic bomb. So this is the bombs that were dropped over Hiroshima and Nagasaki during World War II. Hydrogen bombs involve hydrogen isotopes, which means that there is nuclear fusion that causes the explosion to happen. But the difference here is this: hydrogen bombs actually have two explosions. The first one is nuclear fission in order to create that condition of very high temperature and pressure so that the hydrogen isotopes can fuse together through nuclear fusion. So atomic bombs, one major explosion. Hydrogen bombs, two major explosions. One nuclear fission followed by one nuclear fusion reaction. So visually, how we tell the difference is, now every time the nuclear bomb explodes, it produces a mushroom cloud, just like the one you see in the diagrams over here. So atomic bombs have one mushroom cloud because there's one major explosion. Hydrogen bombs have two mushroom clouds because there are two major explosions. So that's how we generally tell the difference visually, whether it's an atomic bomb explosion or a hydrogen bomb explosion. So to finish up this video lesson, a quick comparison between nuclear fission and fusion. So nuclear fission is a process of a large nucleus splitting into two smaller nuclei. It's able to produce a chain reaction, and this is normally found in nuclear power plants. Nuclear fusion is the opposite process. It's a process of two smaller nuclei forming one large nucleus. It requires very high temperature and pressure for the reaction to take place, and this normally happens on the surface of the sun. And that's it for this video lesson. So I hope you found this video educational and helpful. If you did, please click like and subscribe for more educational videos from your physics teacher, Miss Hu. Happy studying!